All right, we're going to do another example of finding the area between two curves using desmos as our technology. For this particular example, our functions are y is equal to secant squared x and y is equal to cosine of x. And we're going to want to make sure we correctly identify which is which for the purposes of the order of subtraction. When we're using this formula, it has to be top curve minus bottom curve. Now, you may not know off the top of your head what secant squared looks like, but you should certainly know what cosine looks like. So cosine is going to be the bottom curve, and then the secant squared is going to be the top curve. Right, before we start working on this, I want to take a quick check to make sure I'm in radian mode. Everything we do in this class is radians, unless we're told otherwise. I already set up some window dimensions so I can nicely see this shaded region in its corresponding graph here, and also leave space so we can see this original problem here that I pasted into the picture. All right, I'm going to make my f of x the 2 secant squared. One of the advantages of doing this in Desmos as opposed to doing it on your graphing calculator is we can actually type it in pretty much as it appears in normal paper pencil expression here. 2 secant squared of x looks exactly in Desmos like it does on here. Graphing calculator, we'd have to put in the secant as 1 over cosine, and it gets a little bit messy with the parentheses. All right, my bottom function is going to be my g of x. That's going to be cosine of x. And we don't need them for the purposes of calculations, but for the purposes of visualization, what I'm going to do is put in those two vertical lines for the left bound and right bound. So x is equal to negative pi divided by 4, and x is equal to positive pi divided by 4. So this shaded region that's in here, or it's not shaded, but this enclosed region right here corresponds with that shaded region right there. So I'm feeling pretty confident that I have this typed into Desmos correctly. This picture lines up pretty good with the graph I just drew. So I think I'm all set to actually create or calculate the area. So I'm going to go to functions. It's under miscellaneous to get the integral symbol. We're integrating from a to b, lower bound to upper bound. Negative pi over 4 to positive pi over 4. Now I need the top curve minus the bottom curve. I've already set this up, so the top curve is the f of x, and the bottom curve is the g of x, so it matches nicely with the formula as it appears in your textbook. And we're doing this with respect to x, and we get an answer of about 2.585-ish. As I mentioned in the previous video, one of the disadvantages of using technology is the fact of we're not necessarily going to get the exact answer. That 2.58 number, if that's coming from something trig related, that's probably some kind of rational expression. It's actually 4 minus root 2 would be the exact value we get if we were to do this using paper pencil calculus. For what we're trying to accomplish in this unit in our class, the decimal approximations are good enough for most of these. So you're not going to have to worry about that exact value for the purposes of the associated worksheets, problems out of the book, or the next quiz that's coming up with this.